Welcome back to our today's lesson. In this channel we make chemistry friendly for you to understand in the best language possible, in the best way possible. So stay there, have your notebook, write good notes, and ask any question that you might be having. So last time we talked about sodium. We saw how it was losing only one electron, and today we will have magnesium as our next example, so that we can also see how it will be losing its 2 electrons that are in its outermost energy level. So make sure that you're writing good notes, make sure that you'll follow me step by step. So magnesium is the atom that we'll be dealing with. So remember, for magnesium, it is in group 2. It is in group 2. It has atomic number 12, and the electronic arrangement is 2.8.2. Being a metal in group 2, it reacts by losing the 2 electrons in its outermost energy level. So that is where we will begin, by noting that magnesium is in group 2, and group 2 elements are known as the alkaline earth metals. It has atomic number 12, electronic arrangement or electronic configuration is 2.8.2, and being in group 2, it reacts by losing the 2 electrons that are in its outermost energy level. So these are actually the 2 electrons that magnesium will be losing, these 2. Another major point to note is that when magnesium is atomic number 12, last time we said atomic number is the same as the number of protons, and it is also the same as electrons, and it is also the same as the number of protons. They are also 12. Another point to note is that electrons are negatively charged, and protons are positively charged. So those are the things that you get prepared with before you continue with how magnesium will be losing the 2 electrons. So having done all that, and I hope you have just written those major points, we will then go to how magnesium will be losing the 2 electrons. So after we have had that preparation of the major points that we need to know, we then write on this side magnesium atom, and on this side we write magnesium ion. with the name magnesium ion, and this side we have it as magnesium atom. So next we are going to write downwards, vertically downwards, the number of positives, which are 12, and the number of negatives, which are also 12, because as we said last time, an atom is electrically neutral, and the reason is the number of protons and the number of electrons are equal. So go with me as we so let us indicate them downwards together. So the number of positives on one vertical line, the number of negatives on another vertical line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 of them. So make sure that you also count yours. They are supposed to be 12 positives and 12 negatives, and they are supposed to be on the same line. So if you draw a horizontal line, both of them, the positive and the negative, should be on one line for an easy counting, so that you make sure that none of them will be in excess than the other. So by the time you are reaching this point, you are supposed to have a net of 0. And this one we can confirm, we have 12 negatives and we have 12 positives. I shown you last time how you are supposed to deal with such a calculation. You say you have a debt of 12. You have a debt of somebody of 12 shillings. And in your pocket you have plus 12. You have 12 shillings. If you pay the debt, how many shillings will you be left with? Actually, you'd be left with a 0. So I need to say at this point, though we never said in our last video, but at this point, understand this: when we say that an atom is electrically neutral, it is like to say that the overall charge on an atom is 0. We cannot say it is positive or negative. For an atom, it is neither positive nor negative. Actually, if we were to write the symbol for magnesium, at the top here, we do not have any charge now that it is an atom, because the overall charge is a 0. We have a 0 there, and the 0 is coming from when you add, when you have the total number of the electrons and the number of protons. In total, we have it as a 0. So that is the magnesium atom. Then we go to the side of the magnesium ion. At the same, just as we did for the magnesium atom, we will also have 12 positives and 12 negatives. So we do them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at the beginning, both of them are supposed to be the same. Let us confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So by the time you are to this point, it should look like the one of the magnesium atom. But remember, we just said at the beginning that magnesium has atomic number 2.8.2. And being in group 2, we say that an element is in group 2 when we check on the outermost energy level and we see that it has 2 electrons. So if it has 2 electrons, it means that it is in group 2. And being a metal that react by losing electrons, and this one will be losing 2 electrons, so the side that you'll be losing is the side of the negatives, because these are the electrons. So for us, what we will do, we will rub 2 electrons from the bottom. We rub this one, and we also rub this other one. So these 2 are not there anymore. Let me also rub this line that is in between. So we have rubbed the electrons that were one for this positive and another one for that positive. So from there, we are supposed to indicate only this line from the top to the bottom. At this point, each and every positive has a negative to cancel out with. But when we reach down here, these 2 positives has just lost each a negative. So that means when a magnesium loses these 2 electrons in the outermost energy level, there will be these 2 positives that will be left hanging because their fellow negatives have just been lost. So when we be writing the formula of magnesium ion, we will write the symbol for magnesium and then write these 2 positives on the top, like that. And then to write the final symbol for magnesium ion, we will indicate capital M, and then we add these 2. What are these? They are 2 positives. And just like we are saying them, 2 positives. We are not saying positive 2. We are saying how many are they? 2. What are they? Positive. So they are 2 positives. So we say they are 2 positives. So this is the correct way to write the formula of magnesium ion. If you write it as capital M, small g, and a positive 2, it will be wrong, because when you begin with the charge followed by the number, that one will be the oxidation number. But for the charge, it should strictly start with the number and then the positive, because as we were adding them up here, we said in words, these are 2, we say they are 2 positives. So you begin with the 2, then you then next write the positives. So I hope you can see what we have just done for you to understand how the positives are coming about. So that is how we do it. Then finally, there is something else that I want to show you about magnesium. We can write some equations here, 2 of them, and one of them is that we have magnesium atom which is losing 2 electrons to form magnesium 2 positive aqueous. So that is one of the equations that you'll be having. And this is actually the interpretation that Here we had the magnesium atom. It is the one that has lost these 2 electrons, so that we can have the magnesium ion. So Mg, this is the magnesium atom. It is in the solid state. Minus here means it is losing 2 electrons, losing because it is a metal. And then we end up with magnesium ion. But we usually avoid having this negative on the left hand side of the equation. So the final equation will then be, let me write it on top here, the overall equation. So this is the equation that you start with. The second equation, which is actually the overall equation for that case, now that we are saying we always avoid being left with a negative on the left hand side, and just like we do in the normal mathematics, we just take this one and we take it to the other side. So it is the same equation, only that the negative has been taken to the other side. And when you take it to the other side, what happens is the negative will become positive. So it will now be Mg solid. You put the arrow, you write the Mg2 positive, and you're not supposed to have the letters very close to one another. So let me write it correctly. Mg2 positive, it is the aqueous state, plus 2 electrons. So this is the overall equation that you should have, and when you're writing them, they should be these 2. You begin with this one, then you show how this negative is going to the other side, so it comes to this side. You see these state symbols, you're not supposed to write them down here. They are supposed to be at the front of the chemical symbol, in a way that if you draw a straight line, nothing will be left down there. So that is all. For your assignment, I need you to try the one of aluminium. Remember last time we had sodium, we saw how it was losing 1 electron. We have now just done for magnesium, and we have just seen how it has lost 2 electrons. So can you now please try the one for aluminium, and we see how aluminium ion can be formed. It will just be losing 3 electrons, so you'll see how many positives it will be left with. And I would wish that you write it first with the 3 positives on top, then you combine them to have 3 positives. So may you have a good time. Remember, in this channel we try all we can to make chemistry friendly to you, so that we can assist you to have a change of attitude, because when the attitude changes, you will one day smile, wondering how chemistry was hard. It has never been hard. Remember, you just need a change of attitude. Keep on working hard towards changing your attitude. Then you keep on working hard. In this channel, you listen to more of the subtopics. Ask as many questions as you can, and together we will make chemistry friendly and achieve the best grades ever. So I'm wishing you a good time. Hard work pays. Keep it on. Jennifer, our chemistry official, where we make chemistry friendly. Please subscribe, please tell a friend, and may you have a good time. Thank you.